Hello Year 10 mathematicians. We're just going to continue with the Year 11 textbook Unit 6, the number section, and today we're going to move on to fractional indices. Now we've done a lot on index form in Year 10 and a lot of stuff on index rules, and when you multiply numbers in index form you add the powers, divide numbers in index form you subtract the powers, and so on. But the index rules, that's only about half of them, there's a lot more. And today is when you take a number and you raise it to a fractional power. So the easiest thing to start off with is try and use your calculator to kind of work out what fractional powers actually do. And the easiest thing to try and do is pick some random numbers and raise it to a fractional power. So let's just pick on a random number. Let's pick on 9. Raise it to a fractional power. Let's go for a half. So 9 to the power of a half gives 3. Okay, so 9 to the power of a half goes to 3. Let's pick another random number. Let's pick 25. 25 to the power of a half gives you 5. So some of you might already be able to guess what raising something to the power of a half is. It's an operation that you know. It's another button on the calculator. They are exactly the same. And if I pick a number such as, particularly a prime number, it'll kind of give it away. So let's pick 7 and raise it to the power of a half. It doesn't give it away, actually. It doesn't give you as the root. Your calculator, if you've got a newer calculator, it might give it to you as the square root of 7, which means raising something to the power of a half actually produces a square root. Now, the thing you need to know is something to the power of 1 over n. Just done something to the 1 over 2, and that was square root. But if you investigated this pattern in a little bit more detail, you'll realise that something to the power of 1 over n is actually the nth root. Like so. There is an nth root button on the calculator somewhere. Mine is in gold there, and you can pick cube root, square root, fourth root, fifth root, so on. So that's a new index law that you need to know. There is another one. A to the power of m over n. Okay, let's see if we can investigate what that's going to do. So let's pick on, say, the number 4. And remember, if I do that to the power of a half, that's the same as square root. But let's change it to, say, the power of 3 over 2. That goes to 8. So see if you can track back. So to the power of a half was 2. To the power of 3 over 2 is 8. Now, for those of you who are particularly sharp this morning, you'll realise that that's equivalent to doing the nth root, but then raising that answer to the power of m, like so. Or vice versa, okay? This other way is a to the power of m, and then taking the nth root of that answer. We don't really tend to use this other form, so I'm going to just use a pencil and just cross that out. I prefer not to remember that because doing the root first is a lot easier. Okay, let's see if we can apply some of those examples. The main use today is you're going to have to know your square roots, cube roots, fourth roots pretty quickly. We're going to try and do this without a calculator because eventually we have to apply it to algebra. And it's better if you've got a conceptual understanding of square rooting things, cube rooting things, so on. Okay, e.g. number 1 is work out 8 to the power of a third. So using the rules from above, that means cube root. So 8 to the power of a third is the same as the cube root of 8. So for a cube root in your mind, you're thinking, I'm trying to think of a number when I times it by itself 3 times, the answer's 8. And the only number that does that is the number 2. Okay, so 8 to the power of a third would be 2. Right, e.g. number 2. What about 8 to the power of 2/3? So that's the second rule. The denominator is always a root, and the numerator is just a normal power, so that's squaring it. So I always encourage you to do the root first, then square something. So cube root of 8 to the power of 2. We know what the cube root of 8 is 2. So it's 2 to the power of 2, which is 4. Which would be exactly the same as if I did it very quickly, 8 squared to the power of, the cube root of 8 squared, which would be the cube root of 64, which is 4 as well. So you can do it either way, it's always easier to root a smaller number, so you may as well do that first. Right, what about this then? Work out the following. 4 over 25, all to the power of 3 over 2. Now I guess there is a trick you do need to know for this, which is when you raise a fraction to a power, you just do the power to the numerator and you do the power to the denominator separately. And then you end up with square root on the denominator, normal root on the numerator. So you're doing square root of 4 cubed, square root of 25 cubed, and if you simplify those, that's 2 cubed, which is 8. That's 5 cubed, which is 125. So 8 over 125 should be your final answer to that one. Okay, question or easy number 4. Work out the following. Now, you've got numbers in index form, and you have been taught in year 10 a rule about dividing numbers in index form. And it's a division rule called a to the power of n divided by a to the power of m is equal to a to the power of n subtract m. Okay, now obviously I can't use that right now because the bases are different. That's a base 4, that's a base 2. I need the bases to be the same. I can't do anything fancy with that. However, if I try to follow the patterns that I've done above, I end up getting some impossible questions. For example, to the power of 2/3 means I need a cube root first. Now the cube root of 4 is not a nice number, so you're not expected to know that in your head. And remember, I'm trying to do this without the calculator. However, you can use a nifty trick, which is the following. So the number 4 itself is actually 2 squared. I prefer numbers to have the same base, so I can use that trick of rewriting the number 4 as 2 squared. Now there's a rule from year 10 index form, which is if you have an index number and you raise it to a power, you just multiply the powers. And that works here. 2 to the power of 2, all to the power of 2/3, you just multiply the powers. And that's 4/3 divided by 2/3. Sorry, 2 to the power of a third. And then finally I can use my year 10 rule of subtracting the powers. And 4/3 subtract 1/3 is 3/3, which is 1. So it's 2 to the power of 1, which is just 2. So that complicated thing at the top is actually just 2. Right, EG number 5, the last example I'm going to do. We've got an equation. 3 to the power of x equals root 3 to the power of 5. Now, this is called an index equation because you've got an index number. And the problem is you can't use tram lines for this. There is no way that you guys know up to this point, and you won't be taught it in year 11 at all. There's no way to apply operations to this and make x the subject. No way at all. You have to wait until A level to do that. So we have to be pretty clever with this and use a similar strategy to what I did above, which is write everything to the same index form, to the same base. And I'm going to pick base 3. I always pick the smallest number. 3 to the power of x. How could I write the number root 3 in index form? 3 to the power of a half. And that's to the power of 5. Okay, using my index rules from year 10, I know that 3 to the power of a half to the power of 5, you multiply the powers. And you want the powers always to be fractions, never decimals. 3 to the power of 5 over 2. And now if you compare the left-hand side, got a base 3. Compare the right-hand side, it's got a base 3. And you compare the powers, x and 5 over 2. The only way this equation can be correct is if x is equal to 5 over 2. And that would be it. So the questions I want you to do, I'm going to write down, or I'm going to post them in the notebook. But the exam tip I'd like you to follow is if you have numbers with different bases, then write them all to the same base, and it's normally the smaller number. Like if you look at my examples, I had a base 4 and a base 2, I kind of picked the base 2. This one, base 3 was the obvious choice, and you'll get many more in the exercise as well. But yeah, that's pretty much it. If you have any questions, just rejoin the meeting.